Okay, folks, we will make a start. Thank you all for coming to one of the nichest topics, and especially at a developer conference, it could be considered heresy to talk about databases. But who is a developer? Okie dokie. So I don't need to talk about how this works for data warehouses and things. Cool. Okay, so before I begin, yes, there are more normal forms than 3. We will be exploring them. Going past 3 can be useful, despite third normal form being your goal. And we will get into it. But first of all, I wanted to introduce myself. Hi, I'm Steph. You probably guessed that that's me. I run a data science consultancy, and I also focus on data ops. So how can we make analytics automated and take some of the principles from DevOps and stick it in analytics? Because data warehouses, reporting and stuff, it's kind of stuck in the Stone Age. So I really love coming to developer conferences so I can shamelessly steal stuff and put it into practice. I'm a Microsoft MVP. I write books on R. You can get them pretty darn cheap because I self-publish. And you can follow me on Twitter. So that's me. Now we can carry on. So what we're going to cover today is what is third normal form? How do you get there from some data? And why it sucks to have to use third normal form as a developer. We'll then go, okay, so Steph set up the problem. What is her proposed solution? And the proposed solution, or one of the solutions, is 6th normal form databases. So I'll take you through how that works, anchor modeling, and a lot of the benefits, and some clear use cases for when you should consider using it. So no DBA, it depends answer, just a nice checklist so you can say, yes, this situation is my situation. I should consider anchor modeling. So drilling into third normal form, the definition of third normal form: no repeating groups per row, no partially dependent attributes, and no dependencies except on the key. Of course, that requires a whole lot of background. So instead of doing more of the complicated database modeling terminology, I thought we'd work through an example. So we have some data. This exists in your database. Somebody has a customer table. It has information like names, how many people share the same name, what my job is, and because I'm a data scientist, who data scientists hang out with, which is other hipsters, address details, and some purchases. So I buy a lot of beer. I haven't yet got around to buying anything else. So this is your unnormalized, denormalized data, right? So what's bad about that? What are the problems with this data? Like if this was in your database and you were a developer and you were having to code against this, what problems are you going to encounter? Yep.
Redundant data.
Redundant data. Yep. Anything else? Gigantic table size. We've got purchase 1 and 2. Do we really want to restrict our customers to only purchasing 2 things from us? Anything else? Yep, there's a lot of ambiguity. So if you had a lookup for this kind of thing, that would work, but otherwise you could end up with some typos and things in there. Okay, so if I misspelt something in that table, it would be very hard for me to specifically call out a customer with the surname Locke and fix it. I might end up fixing all the Locks, which would be a problem. There's a lot of repeating info. There's limits on how much people can purchase. There's things that are dependent on other columns. And the table says customers, but so much of that info isn't about customers. It is pretty weird to have all of that together. So we can start tackling some of the issues. So the first normal form does not contain repeating groups in a row. What that means is instead of purchase history, item 1, item 2, item 3 as columns, instead those should be a row for each purchase. So you don't have any repeating groups going across in your columns. Now, the nice thing about this is our customers can have unlimited purchases, but there's still a load of our problems. So we got through one of our problems, which is the purchase limit. But we still have a whole bunch of issues. So maybe second normal form will solve it for us. Second normal form involves no partially dependent information. So if first name and surname were your ways of identifying a customer, that would be considered your natural key. Of course, first name and surname is a bad idea for considering somebody a unique person. All those John Smiths are really going to get in our way. But the number of people with the same first name is partially dependent on your key. So part of your key, first name, if you know that, you know the answer to this piece of information. So we split that out. So now our data is in second normal form. Still not particularly good, right? So we solve a few things. We're now down to only 3 big issues. And we've still got all the repeating info, got all the info about customers. So third normal form. Third normal form has no conditional dependencies. So the population of a country was not dependent on the key, but it was dependent on another part of the table. So we split that out into its own table, and now technically we have third normal form. But there's still things wrong with that, right? So what's still wrong with it? Yeah, IDs. We still can't do the update based on a specific customer instance. But we still have purchase history in our original table. Third normal form says that's okay. So you're probably thinking, wait, have I been thinking about third normal form wrong? And you would be right. Actually, hopefully most of you build your databases to what's called Boyce Codd normal form. Boyce Codd normal form says only information about an entity in a table. So purchases is an interaction that we should split out because it is about the customer entity and your inventory entity and how they relate. So you would split out your purchases and then use a customer ID to relate to them. So this is probably a lot more like what you're already doing. So pretty niftily, You just jumped 2 normal forms, because Boyce card normal form comes after 4th normal form. So when everybody else goes, yeah, you need to get your database in 3rd normal form, you can go, I get mine to Boyce card normal form. And sound instantly Swisher. So, So, are there any problems with this schema now? That one. You're probably pretty happy, roughly, with this schema. You keep lookups and things in separate tables. You've got purchases in a nice, easy, narrow table. You'd probably be quite happy with this in production. It looks good. This is what we've been told we should design to. But as developers, when we're working with our application and our data conceptual model, we still have a whole bunch of problems that don't necessarily relate to the normal form, but the way that the tables end up structured. So you've got your database. What are the problems that you encounter and frustrate you about your database? When you're making a change in your app, what are the problems that you encounter?
When you want to update the database model, we have to copy the data over and get it up and running with default.
Yeah, it takes a lot of work to, if you want to change data, you have to maybe set up a new table, copy the data across into it, and then roll over, which makes your deployments really complicated. Any other issues? Who understands indexing? I don't. Indexing is hard. If you have all those columns going across, and you've got your, however you write your queries, you can use indexes to improve it, but then you have to understand about indexes and apply them in a way that your DBA doesn't want to kill you. Because they're a raffle bunch, DBAs. So what other problems? Pardon? Read performance, yeah. Any others? Okay, I think I gave the problems with the DBA, with third normal form for devs, but maybe I overthought. So change gets riskier over time. You've got your application with you've got 8 million customers. You want to add a field to your customer table because it was put on a form by a product owner. It gets kind of nail-biting, going, I need to add a column to an 8 million row table. That could take the database offline, or the performance is going to be slow. What if I screw it up? What if my statement doesn't work? The longer you use your third normal form database, the scarier it gets to make changes. Again, your DBA will probably kick you for this. If you write select star in your database, and then somebody else adds a column, then it can really break things. Then how do you know that your dev version is the same as your prod version? How are you managing schema change and promoting that through your environments? It can be pretty difficult to do that. Then, as you make changes in an established system, it can take a long time. Like, what if you need to re-index or change a data type because you thought, yeah, we're only going to get 32,000 different occupations, and then somebody comes along with the 32,001, and you now need to you need to change the ID from a medium int to a big int. It's difficult. Then, when it comes to version control, do you keep, who here has their database under version control?
Database schema.
Database schema. Yeah. Okay. How do you manage database change? Do you keep do you use something like SQL Server database tools where you have your desired state for a database? Or do you have the initial version that somebody made and then a series of scripts that have to be executed in order to recreate your database state? Who has a desired state database? Who has a migration script database? Yeah. What happens if one of those scripts gets executed out of order? Like you move to SQL Server on Linux, and the file system has a different natural sort order on your numbers than Windows does. So then things get executed out of order. What happens if somebody replays those scripts? Will it break? Can you safely deploy your database schema again and again? Yeah. Right? And then how do you know who changed what and when? It can be pretty difficult, right? So third normal form databases are pretty troublesome. So you end up with availability issues, indexing is hard, DBA shout at us, customers shout at us. It's difficult to implement changes safely. If you've got lots of optional fields, then you're storing nulls everywhere, right? And then you have to handle nulls in your database, in your front-end code, and it causes like storage bloat, and again, the DBA shout at you. It can be really hard looking through Git logs to see what changed and when. And understanding how the schema has evolved is difficult, or which apps are working with which version of the schema. There are more woes. Changing data types, that is effort. Or what if you need to correct if you need a new version of a calculation? Change tracking's hard. And then this other one, who has eaten their own dog food and built reports off of the database they've built for their applications? Okay. I highly recommend that you do at least one report for a business user off your database to prove that your database is usable in other contexts than your application, because it has to be. And until you've written a query to satisfy a business user, you can't know, and you don't feel the pain. And a lot of people really want to be certain that you can prove the values you showed at a specific point in time. And doing change tracking in a third normal form database context is usually pretty difficult. How can you easily say, user Bob, last Thursday got shown this screen? If you're in a regulated or a healthcare type of environment, you need to be able to say that. That's really hard in a third normal form schema. And this is why NoSQL's the answer, right? Let's just do document store and we can worry about the schema later. We can make changes as we need to. That is an acceptable solution in a range of situations. Sixth normal form is another solution for another range of situations. So, what is sixth normal form? This is complete normalization. So if you imagine or think back to our first denormalized data, that is everything as columns in one table. Sixth normal form basically does this. Every table principally contains the entity key it relates to, so like the customer ID, and then has a column for a specific attribute. So every attribute in your third normal form column, in your third normal form table, would now have its own table. So this is what it would end up looking like if you were handcrafting your sixth normal form data warehouse, line of business system. That is some crazy stuff, right? Imagine writing all those joins. You're not going to want to do it. So we want that flexibility because if we wanted to add a new column to our data, to our conceptual model that our app is going to use, that's an extra table with a foreign key constraint. You don't have to take your database offline. You don't impact anything else that is using all the existing stuff. You just have to add a new table and start filling it in. It makes the changes additive only. But nobody ever should write sixth normal form SQL queries. It is hell. So we kind of want that flexibility of being able to add tables and stuff, but give us the third normal form that we can use in our applications. So this is where anchor modeling comes in for you guys. Anchor modeling has a great website, tons of video tutorials for getting into the operational, how do you do things. But you build a conceptual model, and the anchor model system builds you an idempotent SQL script, so a script that you can run again and again and will not make changes to your database if those changes have been previously applied, and does it from effectively a full conceptual model. So let me just see if the Wi-Fi is fine and show you. Where is my... Let me just extend and duplicate instead. That'll be easier. Okay. So the system has a nice online thing, and it uses like D3 and force-directed JavaScript stuff. Pretty nifty. And you can build your model using this GUI. You can also build it through the underlying representation. But this system allows you to build a model of how all the entities interact inside your application. And you can build your model for your app. The other team can be building their conceptual model. You can deploy them both to the same database and then have connections between them for where they hook together. So you can safely use this in a team environment. So you have the idempotent schema. So this is the current state, and you can run that script against any version of your database. So if you have an old version sitting around in your UAT environment and you want to run the dev version against it, you just execute the SQL script. You can safely run that SQL script again and again. It has some strong advantages for if you need to do some interesting stuff. So it has multiple concepts of time. not only do you have the time something happened, so if a user directly edits a field, you can say the change happened at that time. But you might have processes that happen after a change happens. So a person walks into the doctor's office and gives a change of address. The event happened when they handed the slip over. You might need to record that because that's when the change should be valid from. But the receptionist won't load it into your application for another 6 hours until after the surgery closes. The doctor might have made decisions about where to send prescriptions or letters in the intervening 6 hours to the new address, but your system wouldn't know that 6 hours later. So you have the time an event happened, the time an event was recorded, and you can also then add a further notion of time of when an event was evaluated. And when you evaluate an event, you can add a reliability measure. So these are optional attributes, optional capabilities of Anchor model that you can enable. But if somebody goes onto your app and says their salary is now £1 million, when all of your other customers' income is between 0 and 200 grand, you could add a low reliability marker against that. So downstream, you could kick off an asynchronous process to get that data vetted, and customer services could go in, update it with a real value, and assign a high reliability to that new value. Or they could confirm it and change the reliability to 1, that you're certain that data is correct. So if you need to be worried about data quality, or to add multiple people's opinions about how likely something is to happen, you can enable the reliability measuring and have this baked into your model without you having to write any specific code to make that happen. It does version control. It records every version of your data as it changes if you want to. So this makes it fantastic for being able to rewind your application and say, this is what a customer saw on a given point in time. Because all the changes are additive, you do not need to take your database down. Because you're not impacting existing tables, it is safe to add new tables. That is great. That means no downtime. I love no downtime, especially when I don't have to do complicated things to achieve it. So the model is pretty simple. We'll look at what makes up an anchor model. It's also really great for a data warehouse for most of these reasons. It works really well on a column store database engine, and it is cross-platform. So you can get it to generate SQL Server specific, a SQL Server specific database implementation, or an Oracle, or Postgres, or MySQL. And because everything in the database is basically, you can effectively think of it as 2 columns, the thing it relates to and the thing you're talking about, it is wonderful in a massively parallel scenario. So from a scale-out perspective, it becomes pretty nifty. So what's in a model? In an anchor model, when we say anchor, we're talking about entities. So your anchor will be a customer, inventory, staff. Then you have attributes. So these are the things about entities. Knots are your lookup tables. So you probably already have a bunch of knots and then a constraint that says the values in my database for this field must be in this existing set. And then ties are how your entities interact. So you have some new words, but you probably already think of this stuff when you're building UML or use case diagrams, right? You have your actors, how they interact, things that you need to track about them, and constraints about what they can say. So those are the main components, and then you can set up some different concepts of time. So you can make something static to just have a single value. So you're not going to worry about change tracking. You can then make something historized to track the changes. So whenever you update a value, the old value will be stored with a beginning and an end date. And you can then use a point-in-time view to say, what was the value at a given time? Or what changes did this value undergo between these two dates? And then concurrent reliance temporal, which is definitely a mouthful, that is where you have the reliability indicators. So you not only have the concept of when things happened, when they were recorded, but also when they were evaluated for reliability. So you're probably not going to turn this one on without a lot of thinking, but you can use these two in the same model, right down to the same anchor. So you can say, well, people don't really change their date of birth, so I'm going to keep that as static. But where people live, they change that fairly often. So I'm going to make a historized view of all the fields in address so that I get the change tracking. The really nifty thing is about this that it doesn't have to be an all or nothing scenario. You can do a little bit in this. You can make a new version that it's historized or static and revert back. You keep all your old data and you just add this new section. So how we do the work, you can use their GUI, and I will admit to having a lot of fun dragging things around and seeing all the layout sort itself out. It has an XML schema. So yes, it's XML. I know that's kind of out of vogue. But because anchor modeling is open source, you can make a version of the translation engine to use JavaScript entirely. You can take your third normal form schema that you have already, apply some SQL scripts, and it will generate an anchor model representation. So these are mentioned on one of the posts on the home page. So you could go and experiment without even having to go through a modeling exercise. You can take your existing database, give it a go, see what it feels like. And you can bring your own. It's an entirely open system, GitHub repos. You can make changes, recommendations, implementations. So modeling your data, you start with a blank canvas. Here is an anchor. And I'm doing this because I couldn't guarantee internet. So here's the example model which we can build. So squares are your anchors, diamonds are your relationships, and circles are your attributes. And everything has metadata. So you have your descriptor, which is your nice, pretty name for a field. You give it a shorthand TLA for attributes. You can say what schema it belongs to, and you can give it a longhand description. So you can be putting information about how you expect your model to be used, or concepts that are important, or like Jim Bob required this attribute. You can put that information in there. And then you can say whether it has a lookup or whether you want to do change tracking. And you can do it from inside this GUI. So you build your model like this. And then the next step is to get ready to do a deployment. So you can use the GUI, or there is a JavaScript utility file called Sysulate, which will take an XML file representation and convert that into another form of output. So,
sorry, does it actually have a type? I didn't see a sort of type thing like in.
yes, it does, but when you create it, I'll show you how to do that at the end, just so I maintain my timings. Okay, so you get the things. Once you have the file, once you have a SQL file, you can run that against your database. And because it is just a JavaScript thing that you can do in a command line, you can then put it in your continuous integration and deployment pipeline. Your schema, your database gets generated from a state. So you can do a clean state build, or you can do a regression test or integration test where you apply it to an existing database and run a check to make sure that it is okay. So it's quite nice and easy. You hit SQL code, it does the sysulation, which is also just a great word. It had various options, like do you want to build partitioning in? It has some extra nifty bits. You can get a JSON representation of your model. The really nifty thing is it automatically documents your database. Ta-da. If you've got your descriptions and stuff in, it's great. And you can click through to say, what does this relate to? Got all your data types. I love it when I don't have to document something, but something is documented for me. So once you have your database deployed, you then have to start using it in your application. So it provides a whole bunch of third normal form interfaces and has nice business names as well that you can use. So common application actions: create, read, update, delete, CRUD. So when somebody says you have a cruddy app, it's not necessarily a slight. Create is an insert, read is a select, update is an update. And because this is all about keeping data as much as possible, it is relatively difficult to delete data. You can, but the easiest way for most situations is to just put a toggle, an attribute, which has a 1 or a 0 for whether a customer should be deleted. So you could do the soft delete toggle, and then if we're thinking GDPR, right to be forgotten, you can then do a more intensive process to cascade through your model, which, because it's very clean and simple, it's really easy to say, these are the things impacted by this customer, to do a full delete. So you might have a select. You don't necessarily have to select all of these things, but they have these metadata columns. These metadata columns tell you what version of the schema the data was inserted or updated under. So if you do a schema change to work with your app, sort of like a forked version, then you can say, this is the data that my app wrote. Or if you have a legacy app that is still running on an old version, when it's making changes, you can tell that. You also get to see when data changed. So you understand its freshness. So a select statement just kind of works as usual. Insert, when you insert, you should make sure you have your metadata ID. And you can, let me just do, can I? I've hard-coded this, but whenever you make a new schema or make a new evolved version of your model, it goes into a schema table and gets a number. So you can link that to your commit through your, and put it in as a config value or something. Or you can hard code it to give yourself a fixed point in time. That depends on how you want to work. And then we can insert values. So even though it's sixth normal form, and even though we're inserting an actor, the actor name is actually a different table to the actor ID. We're still getting our interface. And then when it comes time to do our updates, let me just make sure it wrote. We can change it by referencing the original anchor ID. And get changes. And even though there are all these other attributes, we're only writing data into the one table. This means we're only storing as much data as actually exists. It reconstructs everything to say, I don't have information, but you're not ever having to store an absence of data. This makes your system much smaller relative to a third normal form database, even though it has this sheer volume of tables, right? And it has various bits of metadata, like when things changed, so that we know about those. What was I going to say? But the advantage of only having data that is filled in, not only do you have a storage benefit, but it makes it much easier for your database to compute statistics about the distribution of data in those columns, which means your queries become more efficient without you having to do much, without you having to do anything. Okay. So when it comes time to change a schema, you can make a change in the GUI. Any prior model is a valid state. All the prior versions, so let's say you need to go from a 32-int to a 64-int version of something, because woohoo, lots of growth. The 32-int version for all the old data can still live in your database, but your new version of the app can point to the new 64-bit version, which you populated as part of with the old values. So you can correct your data, use the new point-in-time version in your app, but old versions or fixed things that you couldn't change can still be using the original table. So if you have different versions of your app in the wild, they can all still use different database states, but still be working from the same database. So you can do a change in a GUI or a system. I used to have this for a data warehouse. So I was able to add a new value to a table in my metadata database. And then every hour when my ETL would run, it would detect changes and regenerate the SQL script and deploy new data, deploy my schema change. So you can have this inside a continuous delivery operation, whether you generate the XML and check it in, or whether you have something that generates the XML and the downstream SQL for you. And then I would recommend you increment your metadata tag so you know which version of the schema your app is running against. So we have our existing model. To make changes to it, we can use the GUI. So I'm going to add 2 attributes. I don't like having first name and surname in one system. So I can now fill in the information to make my 2 new attributes. This is where you put in the data range. I made the video without putting like brackets 255. You should put that in, otherwise it'll default to varchar 1. And we can historize them so that we have a change track version. And you have to be able to type correctly. What they've done to improve search speed and value comparison is they've implemented a checksum value comparison, which makes it much more efficient if you're storing big values of text or GUIDs or various things to be able to effectively compare. That does mean that you need CLR enabled in your database. So right now, you can't use Azure SQL as a platform for a SIG for normal form database that does the checksum comparisons. And right now, I think the current advice with Spectre and Meltdown is to turn off the CLR, the R and Python integration, and just go back to straight SQL. So that is a consideration for implementing this that you will need to think about. Are we allowed to effectively run C# in our database? Idempotent script, so that deploys. And then our new version of our app ID 2, can do an insert. It can reference only the columns it expects. And that version of the system works. So we now get a second record without actor name, but that has the first name and the last name. So you can keep changes relatively in track with your app. You can do updates. You can be nice and be backwards compatible, and that's still fine. Here is just changing values. And you can just be mean to your legacy apps and just update your new values. So if you're dropping columns because they're no longer relevant, or because a version of the app is no longer supported, you can just insert the data you care about. So you're able to account for effectively doing feature flagging. Okay. So when to use it? They did a really nice paper where they simulated different conditions, different types of scenarios to come up with some nice, easy conclusions. If you're going to track version history, Anchor model's really good for that. It will be much faster than a big database with version history done in a sort of hand-rolled kind of way. If you have lots of optional values, this is brilliant because it's only storing the data that exists. If you have a big model, so this maybe doesn't apply for when you're building like a relatively simple mobile app, but if you're taking a big legacy app that covers a whole sort of mortgage loan process, then you might have a lot of data, a lot of entities and interactions, and this can be really useful. If your model's changing a lot, definitely consider anchor modeling because the changes are additive and you don't have to write the deployment script. So there's no mistakes. I love that there's no mistakes. If you need audit trails, it's really good because it takes care of that for you. And especially if you need reliability measures, then trying to model 3 concepts of time is really hard, and you will spend a lot of time doing it, whereas you could just turn it on. So it isn't an all or nothing. Because it's an idempotent script that doesn't drop your database, doesn't drop tables, doesn't impact anything that already exists, you can use this for a small section of your app and keep the rest in third normal form. And when you should go back or stick with third normal form, if your schema's never going to change. So discontinue out of support thing that's just going to tick over with those few users, then maybe collapsing it back to third normal form to simplify things. If you have lots of search conditions, so the way that the select with where's works is it will use a bunch of the database wizardry behind it to not have to join everything. But if you have lots of search conditions, then it has to join all of those tables. So if you had 10 conditions, that will probably be a slower query in sixth normal form than it would be in third normal form. If you have low data volumes, then the overhead of lots of tables will probably mean that your database is a bit slower. If you have lots of lookups, so the knotted attributes, that can be a little bit difficult. And even though the database can do clever things around performance with this, it may still be a little bit slower than a third normal form version. in a number of these scenarios. So what you would, if you need that extra millisecond, and it isn't that you can turn on the partitioning or turn on use a column store database, then you might want to revert to third normal form. But these are the criteria where I would suggest you give anchor modeling a go. Okay. I got through this nice and quickly, so we'll be able to have plenty of time for questions and playing with a model. So, third normal form. Actually, most of you have probably been doing Boyce Card normal form. Woohoo, you got an extra 2. It really sucks as an application dev to have to try and work with a third normal form database. There are things that you can do to make it better, but this really is one of the big driving forces for the swing back to document databases, because managing databases through schema change to match your application is fundamentally difficult because of the way that databases work. Anchor modeling, by splitting out every attribute into its own table, means that those changes to your model, to your application, become additive. You don't have to run big updates. You don't have to run alter tables. You don't have to have an indexing strategy. You just add an extra node to an XML diagram, to an XML file. Or have a business analyst use a GUI. Or you use a GUI because you like chucking things around. Because of the JavaScript file, it sits inside your CI/CD pipeline to help you move faster. And again, because it's additive, it means that you don't have to request offline database time. It puts things back in your control to save you having to do synchronized processes with your database team. You still use third normal form views and functions that enable you to get the latest view, the view in a point of time, and a list of changes that have happened. You're able to query the schema to say, what did the schema look like at a given point in time? And you're able to tie your application to a specific, or tie your database to a specific version of your application. So you're able to trace the impact of a version. If something goes wrong and you need to just do a big undo for a given state of your application, you can actually say, delete anything with a metadata ID of 99, the release we'll never speak of again, and it'll wipe all the changes. So you can do that. You should consider this for when your database is undergoing a lot of change. When you have lots of optional values, when you need to do version control or tracked changes. These are really good cases for doing this, and when you need to be able to add in multiple concepts of time. So if you have processes that might happen offline, by being able to record when an event happened, but when you loaded it, that can be very useful. So thank you for coming. Thank you to the organizers and sponsors and stuff. What I'd like to do now is go over to Q&A. You can drive me using anchor modeling. If you go to italog.com/talks, the first entry is for this talk. You can get the slide deck. You can also get a GitHub repo, which has example code for a bunch of these things. It has some glossary and some more detail, and we can drill into those. But it means that you can take this away and look at it more intensively than a Friday afternoon after 3 days of solid learning. So that's why I wanted to keep the main theory bit kind of short and sweet so that we can have a play and answer questions and things that you've thought of through this. So, questions? Yep.
You said that if you have multiple versions of applications, that the old version can use the old tables and the new version can use the new versions.
Yeah.
How is guaranteed that during the deployment, when the new version and the old versions are not simultaneously live, they basically use different tables? So how do I keep the data synced?
Yeah. So the question is, with a given version, wait, for some reason I thought I only talked for like half an hour. Okay, you can all leave whenever you want to. I'm not going to keep you here. So let me just duplicate this. So my database here, the attributes for a given thing. So if I'm adding a new field about actors in this case, it's going to be a new table, and it will drop the old version of the view which says actor has these 10 columns, and there'll be a new version of the view which says actor has these 14 columns. The old tables, the old columns, don't go away. The old application would continue using its select statement that it always had, and it wouldn't see any change. Your new version of the application would use a new select statement that refers to the new columns. So it would see it's put the bits that are relevant to your new version. Your old version would see the old columns.
Okay. This is for the reading part, but for the intent, let's consider the fact that I will, for example, change the type of first name, so it will create a new table, and the old application would actually, or I guess, insert into the old table, and the new application would insert into the new table. So, like, the old application wouldn't get the first name from the new version and vice versa. And after I shut down the old application, I need to make sure that all the data that was saved by the first application is transferred to the new tables. Right?
So in the event that you have to synchronize data between two of the tables, the inserts work through triggers on the views and processes. So you can set up your own independent synchronization script. You can potentially modify the trigger that does the insert. So you can change your anchor model, but I would recommend an independent script that does that data synchronization, especially because that, by thinking of it as application compatibility between versions, you probably are already thinking about the life cycle of your versions, how long you are going to support them, and what changes you need to make to keep them in support. So that application support usually kind of has its own folder of stuff you're doing. So you might have like a halfway house CSS sheet to make the old app kind of look like the new app without rebuilding all the frames. So that kind of process would sit in there in your migration lifecycle planning. Yeah, cool. Any more questions? Okay, so you have the files, you've got the presentation. Make sure you grab stickers and cards and stuff. If you follow my company Twitter, I give away a book a month, usually kind of data science focused, but very beginner stuff. If you have any questions on this, you want to play, I do office hours. So you can just go on itsalocke.com, go to schedule a call, and book in half an hour. All my availability is plugged in. So if you want to follow up with me on this, you can email me or you can schedule a call. And we can have Twitter conversations. Now that there's 280 characters, I can talk normally. Thank you all for coming today to such a niche topic, and hopefully I've inspired you to give it a go on at least a toy example for your environment. Thank you all very much.